differential equations is not actually enough. I need to talk about differential equations and boundary conditions together. And that actually raises issues about uncomputable representations. And there is a methodology which is called symbolic dynamics, which is a way to do this, and I'll talk about this tomorrow. So I'm going to do a little bit tomorrow about this notion of symbolic dynamic representations of deterministic non-periodic flows. The states are basically represented by multiple symbol strings, and if you have say two systems, two of these types of systems where the symbol strings are correlated in some sense, that denotes some type of synchronization. So chaotic synchronization is a very important process in chaotic dynamics. So two systems which behave completely irregularly can nevertheless come into synchronization if they're so coupled. So that's the first part. The second part is to say, how can you reformulate quantum theory so that it might fit into this framework? So the second part of the talk tomorrow will be to try to discuss kind of the standard, that's called Hilbert space representation, where you can try to think of quantum states as these symbol strings. And complex structure will be, I'll talk about permutation operators which have quaternionic self-similar structures. But I want to introduce the idea of entanglement in terms of these symbol string correlations. And then finally, the perhaps $64,000 question is the linearity of the Schrödinger equation. How is that encompassed in such a nonlinear theory? Well, I want to talk about the existence of linear structures in symbol space, which can perhaps model this type of. So I'm trying to, in a sense, bring in some new physics to do with nonlinear dynamics into standard quantum theory. And my belief is that will.
How many dollars do you say?
Yeah, well, but is Basil? Oh, he's gone.
No, I'm not. I'm here.
Oh, you're here.
I'm just. Oh, you've got the quote.
Because I've had this paper on my desk for a couple of years, and I've been meaning to get round to reading it, and I finally got round to reading it on the plane.
I'm just reading it now.
On the way over.
See what we said.
Well, I only got round to, I'm sort of slightly embarrassed about this, but I only got round to reading it on the plane on the way over yesterday. And you never know with things, when you have a kind of a fixed way of thinking and you read something and you think, oh yeah, that's exactly what, that really resonates. So this is a paper written by David and Basil back in '81 on quantum theory understood in terms of Einstein's non-linear field equation. So they're talking about non-linearity. At the time, I guess, the stuff of René Thom and catastrophe theory was very much in vogue. In a sense, catastrophe theory is about just bifurcations of non-linear dynamical systems. So it's kind of part of the whole framework of which kind of chaos is perhaps a general kind of concept. But they were addressing this issue of could we kind of understand exactly the same thing, entanglement by non-linear types of thinking. And this was just a quote I just took from the paper. We are supposing that through nonlinearity the movements, so they're considering the EPR experiment where they have this source, positronium source, emitting polarized photons. Photons. So this is the source, and then they have detectors A and B. So we're supposing that through I don't know if this is, Basil may correct me, but I thought this was a key sort of sentence in the paper. I'll say I didn't perhaps read every single sentence, but anyway. We're supposing that through nonlinearity the movements of the positronium and of the particles constituting the detectors A and B are coordinated in a certain way, sort of through this nonlinear. So the nature of the coordination is such that the positronium atom decays into two photons with suitably related but well-defined polarizations only when the detectors are in a condition to absorb these photons. This coordination is not the result of pre-established harmony, nor is it like a conspiracy. That kind of resonates to me about this fact that there's this overall, the system, which is the positronium, the detectors, and maybe the universe in some general sense, are governed by this underlying nonlinear dynamic, just schematically this type of overall structure, and that in a sense means that even these dynamically kind of what seem to be energetically unimportant degrees of freedom, you don't have the dynamical freedom to perturb those in arbitrary ways. And you take this, in my language, you take it off the attractor, you take it away from its invariant set. So, we'll see as I go through the talk whether Basil thinks this is at all
Well, certainly,
to the way David.
just rereading what you put on earlier,
Yes.
that's why I went to get my computer, just to check what we actually wrote. Because 81, you know, it's going back a bit.
Just one short of it, Basil. What did you mean by conspiracy?
Yeah.
Well, that was the whole,
That means
the whole
everything
tenor of the
together,
debate was whether there was some conspiracy in nature to fool us into believing it was non-locality when all the time it was locality. I think Vigier had this idea that if you had it all on a tape, so the universe was a sort of a film which was unfolding, then the correlation would have been put in there locally. And as it unfolds, then the conspiracy is that God's designed it in this way to fool us. That was I think the idea of conspiracy.
Conspiracy means literally breathing together, so it's more like what you're talking about.
That was the debate we had. Maybe
I've been gone into it, really.
well, I'm sorry, I just, you know, how
So I think the key, my perspective on this is to raise this word that Michael raised about counterfactual perturbations. That things that, you know, in most physical theories, you can always, you know, in most physical theories you have an initial condition, but you can kind of perturb that initial condition, and you run your differential equations, and you know, everything kind of happily trudges on in much as they did before. But these type of systems, you can't do that. If you say the system is defined by its differential equations on its invariant set, then you're talking about this low-dimensional measure zero set in phase space, and any perturbation will take you, even if it's infinitesimal in a literal sense, it will take you off that system, and so that becomes now no longer dynamically allowable. Yeah. And in a sense, with respect to the measure of your state space, any such perturbation, you know, with probability 1, will do such a thing. And this is, as I say, consistent with this Tarkin's theorem that any degree of freedom, you know, even if it's totally energetically irrelevant, can be used to reconstruct the entire attractor. It's a kind of it's kind of Marx's principle to the extreme, if you like. So this is the basis of what I want to develop, a kind of more of a mathematical theory to see, you know, and perhaps apart from sort of trying to, let's say, contribute to the discussion about the meaning of Bell and non-locality, what I think I would like, you know, what I'm going to propose that may come out of it is perhaps a new kind of conception of what gravity is. So I think I'll leave that really, because the next slide I think goes on to some sort of math stuff. So it's 5:30 now. I could just give you a quick run through on global warming if people are interested.
Can I just say something very quickly on the historical side?
Yes.
I really found this extremely interesting today. Thank you very much indeed.
Wow.
But just, just on a historical side, and also a question to Basil. I assume that what Basil and David had in mind. Sorry, Basil, I'm listening. I assume that what you had in mind by saying no, it's not a conspiracy was what you had in mind. It's the quantum pretender.
No.
This was definitely coming out of the
This was rejecting.
Okay, this was going right away from this.
Yeah, it was. Because remember, David and I used to have different standpoints in which our theories were actually inconsistent with each other if we tried to view them in the whole.
Right, that's very interesting.
This was to throw the quantum potential and all that to one side.
Put that aside, to bracket that and look at what it would be if it was just
I picked that up in the introduction, that they made that point explicitly, that they said this has really got nothing to do with our kind of...
With your ideas about other possible sources
of
understanding of low and non-locality in terms of the quantum potential. Okay, well that's very interesting, that's historically very illuminating. The other thing I wanted to mention very quickly was that at around that time, 1981, when they published this paper, I don't know if this was at all in your background, in your minds when you published it, but since you specifically cited,